we have covered the topic different parameters of two-port network, and you have a good concept about two-port network, and you also know the fundamental difference between single port or two terminal networks and two port or four terminals network. Okay, and you have seen that there are total four variables associated with a two-port network. These variables are V1 input port voltage, V2 output port voltage, I1 input port current, and I2 output port current. Therefore, total four variables. And you know that the coefficient of independent variables of two-port network equation are known as parameters. Okay, so you can express two variable as independent variables and remaining two variables as dependent variable, and you can express the dependent variable in terms of independent variables. Okay, and the coefficient of independent variables of the two-port network equation are known as parameter, and you know that there are total four set of parameters: Z parameter or open circuit admittance impedance parameter, Y parameter or short circuit admittance parameter, H parameter or mixed parameter, and last one is transmission parameter or T parameter, or also it is known as ABCD parameter. Okay, this total four set of parameters. Okay, now you okay, you can calculate the values of parameter Z parameter values for a two-port network. Okay, there are total four Z parameters: Z11, Z12, Z21, and Z22. You can calculate it, and in last class we have derived the expression of this parameter. Okay, now I will tell you the expressions of Y parameter, short circuit admittance parameter. So after that we will try to understand the conversion approach between the network parameter, maybe Z parameter to Y parameter or Y parameter to Z parameter. We will see that later. So first you tell me, how do you calculate the values of admittance parameter? You have already derived the expression of Z parameter. Now you calculate Y parameters, value of Y parameters, or Y parameters or short circuit admittance parameters. Okay, you find out the values of Y parameters. Okay, so in this case, in previous case when we have considered Z parameter, that time we have considered that V1 and V2 are dependent variables. On the other hand, I1 and I2 are independent variables. In this case, to calculate Y parameter, we will consider that I1 and I2 are dependent variables. So here you consider I1 input port current and I2 output port current of a two-port network are dependent variables. Okay, dependent variables. On the other hand, but V1 and V2 are independent variables. Independent variables. Now you write the expression of independent variables for a two-port network. For a two-port network. No doubt. Now you write the equation which signifies the relation between independent and dependent variables. Okay. Okay, I will do it. I will do it, no problem. On Friday, okay, within Friday you submit it. I will make a assignment for lab experiment 7 today. Okay, no problem, Harshrat. Okay, and now you write the equation between independent and dependent variables. Then we can between independent and dependent variables. Then we can write I1 equal to Y11 V1 plus Y12 V2. Okay, and I2 equal to, you can write, you just understand this thing, Y21 V Y22 V2. Okay, here we consider I1 and I2 are dependent variables, but V1 and V2 are independent variables. We can express a dependent variable in terms of independent variables. Okay, independent variables, you know it. Okay, we can write this thing. And you know that the coefficient of independent variables are known as parameters. So therefore, for this case, parameters are y11, y12, y21, y22. So let's the matrix from of the above, you just write of the above two equation. If you have any doubt, you just write in your chat box. So we can write similarly within third bracket. This is I1 I2 equal to Y11 Y12 Y21 Y22. Close the matrix, and you multiply V1 and V2. Okay, no doubt this is the matrix from of the above two equation. Above two equation, you just write in proper way. Okay, this will become, okay, I1 and I2. The matrix from of the above two equation we can write like this. Okay, now you we make the last date of submission to next. Okay, no problem. I will uh, extend the deadline for submission of lab assignment. Okay, no problem. Now you tell me, how do you write the expression of y11, y12, y21 and y22? Okay, to calculate or determine the values of two-port network parameter. First step is to write the network equation in terms of network equation by considering independent and dependent variables. I mean, you write the network equation as you express the dependent variables in terms of independent variables. Okay, there are total 4 set of parameters for a two-port network: Z parameters, Y parameters, hybrid parameter, and transmission parameter. We have already defined the expression of a Z parameters. Now we determine the expression of admittance parameter or short circuit admittance parameter of a two-port network. Okay. So similarly, as earlier, okay, the steps whatever you have used to calculate Z parameter, in the similar way you can calculate it, but only difference is that for this case you consider port are short circuited, okay, instead of open circuit condition. Let me write here. Okay, I can write y11 equal to, I can write I1 divided by V1, okay, V1 when V2 equal to 0 at V2 equal to 0. V2 voltage drop 0 means what? Voltage drop 0 means the port is short circuited. Okay, voltage is infinite means what? The open circuited. Okay, so y11 equal to I current divided by input port voltage V1 at V2 equal to 0. Output is short circuited. You just write here, that is output port is short circuited. Okay, no doubt. And now you tell me the expression of y12 equal to, you can write from the equation 1 and 2, you just tell me y12 equal to, you can write I1 divided by I1 divided by V2 at V1 equal to 0. V1 equal to 0. That means the input circuited. For this case, input port is short circuited. You just mention here, instead of output you just write input. Input port is short circuited for this case. Now you calculate the value of y21. So y21 equal to, you can write I2 by V1. Everyone carefully see the equation 1 and 2. Then you can easily understand. V1. So for this case, V2 0. The output port is short circuited. The output port is short circuited. That means V2 is 0. V2 is 0. Next you calculate the value of y22. You calculate the value of y22. So y22 equal to, you can easily write I2 by V2 at V1 equal to 0, which means that input port is short circuited. Okay, everyone see the y21 I2 by V1. Y21, yes, I2 by V1 at V2 equal to 0. short circuited. Okay, everyone calculate or determine the expression of y11, y21, y12, y22 yourself and just verify with the expression given in present slide. Okay, if you have any doubt or if you face any difficulty to calculate the expression of this admittance parameter, you would write in your chat box. Okay, you would write in your chat box. Now you tell me what will this parameter. What will this parameter? Now the units of these parameters. Uh, Anyone tell me the units of this parameter? I mean the admittance parameter of short circuit admittance parameter. You see that admittance means what? The reciprocal of impedance, and impedance equal to ratio of voltage to current. For this case, you see that this parameter is the ratio of current to voltage, so that's why it is reciprocal of impedance, and that reciprocal of impedance is called admittance. Okay, now you tell me the unit of these parameters, of the admittance parameters. The unit of this parameter is mho, just opposite of impedance. Impedance unit is ohm and its unit is mho. Okay, so therefore the units of this parameter is mho. Units